Alright, let's try to look at it together.
She got 140, just replace the
1,000. I'm not seeing your picture. But please, let's look at it together and see if we can arrive at something. So if we analyze this, we have our wall, have our ladder, have an angle to it. This time around is 30 degrees, shall we?
Yes.
30 degrees. Then, any other thing?
The friction.
This is the ground. This is the ground. We have definitely our FG now, reaction, that is reaction from the ground. Then we have friction that will be going this way. Shall we? That means if this friction is actually present, there is friction on the wall, hope you know. Okay, then the reaction of the wall, that is RW. Is it? Weight of the ladder. What was it? 70 kg, Chevy. That is, it will now be W equals to 70 times 10. Okay, which is going to give me what? 700 Newton. Okay. You know, say that this camera, they save me 700 Newton. So let me write it here. 700 Newton. Is there any other thing? Let's analyze. Reaction. Then weight of the wall, RG. Okay, so since we are finding reaction on the wall, that means we still make this part our fulcrum. Is it not true?
Yes.
Because I saw what most of you were doing. I tricked you. Yes, I tricked you with that thing. That frictional wall. Have you forgotten that when we are pointing everything to this point, we always ignore these two unknowns? Is it not true? So I'm not going to be checking this. Assuming I'm not pointing anything to here, that is where I will not be considering this my friction. Are you seeing it? Yes. So since I'm pointing this now to this point, the reaction of this one, notice that the reaction of this as it's going this way, the friction itself is acting this way. Backward. This one is going this way. The friction itself is going this way. Is it not? But I'm not going to be considering this because see where my eye is. Just this and just this. I'm not even considering this. Remember my fulcrum is there. Do you still remember? Yes. When you consider your friction, it's maybe they did not give you the angle. Yes. So this question, we will solve this question as number 3 example. When an angle is not given to you, You are to find the angle. This case, they gave us 30 degrees, Shebi. Now, the situation where they did not give us angle. In that case, now, what we'll now do is, we'll now be looking for a way to point the two forces to the center. So our center will now be our fulcrum. So in that case, where the center becomes the fulcrum, that is where we'll now take note of the frictional force acting downwards. Hope this thing is making sense. Yes. So we noted it somewhere. So example 3, I will remove the angle there. Then we'll now find the forces acting. That is the RW. Then we'll now find the frictional force. In that case, no angle will be given. So before you now do it, you now see that there will be a concept you use to find the angle. So in this case, I will ignore this thing. So I'm just going to use the same approach I used to solve the first one to solve this same question. Because what they asked me to find is this. So where I put you on strong hold is that because I talked about having friction, good number of you are going ahead to look for this. Yes. So these are 2 cases where you see this kind of questions. So if I know that, now please, I think the problem we normally have that brings confusion is when I start finding the angle. Is it not true?
Yes.
That's where the issue normally comes. Now, I'm not finding the angle. What I'm going to say is simple. Let's check something. This force, what axis is this force? If you see something like this, is it in x-axis? Chebi is x-axis. What did I say? What did I say you consider x-axis? X-axis on inclined plane is what? Sine, Chebi. So instead of RW, the force here will be simply RW sine theta. Are you seeing it? Yes. Now, there's another force here. Remember, we are pointing out the forces, and these are the 2 forces we will meet. Now, this force, now, if I'm pointing it to this place, this is on y-axis. And what did I say y-axis is on an inclined plane? So that means that this 700 Newton is supposed to be 700 cos theta. Now, the next thing I need to check, is it going anti-clockwise or clockwise? If this thing is going to the fulcrum this way, it's clockwise. And clockwise for a circle is simply, if it's going this way anti-clockwise to in a circle is simply, which means that minus this plus this should be equal to 0. So when I know this, so we don't have to be stressing ourselves resolving. Now, if you want to really learn how to resolve, go and check our first class. I'll still post it today on how to resolve angles on an inclined plane. We took time to do it. We did it for like 1 hour. So if I know this now becomes the sentence I say, when this crossover, because minus will cancel. Or if this one crossover, or I can say, since this is clockwise, this one is anti-clockwise. Clockwise is equal to anti-clockwise, so the signs must disappear. So that this becomes now RW sine theta is equal to 700 cos theta. But remember, that is not just the force we are finding, we're also finding torque. Is it not true? Because the principle we use is the principle of torque, where we say if we are finding a force, direct everything to a fulcrum. Assuming we are finding what is here, direct everything to this. So we must consider the length as well. Now we say from this RW to this point is the total length. So I will say times L. While from this part is the center now, and we know why it's the center because it's the weight of that ladder. And we say center of gravity, we define it as the point of an object towards the center, downwards towards the center. So for that reason, from this part to this part should give me half. So that is times L over 2. You see that it's the same concept.
Come again.
Come again.
That L over 2.
Only Jesus
Can come again.
will come again. See, I said, if this is the full length, and this is the center, Shebi, forget the fact that I did not divide it well, but if this is the center, that means that half of it, you know that is the center that's saying length times the half, which is L over 2. So that is how I got that in. So using this same approach now, I want you to now, let's now replace things there. Our cos theta is the sense in theta here is what? 30, Shebi? And it's also 30 here. 30 degrees here. Now notice something. Let me put it this way. Let me put this way so you don't get confused. Times L over 2. Now, times L. So notice something. This can easily say, let me come here, cancel. Let me come here, cancel. So that I get 350. Shall we? I have L now. And I have L here. This can go here. Is it not true? Let's cancel out. Now, sine 30 is what?
0.5.
So I have 0.5 RW is equals to, cos 30 is what? 0.8660. Then times 350. You will punch it for me. 350 times 0.8660. 30. 303.1. Like this, Shebi? Okay, in Newton. So now see that if I divide both sides by 0.5, so divide both sides by 0.5.
You have 606.
So that means that RW, this will cancel this. So RW divided will not be equal to what?
606.2.
Is it 1? Yes. Okay, which is what? In Newton. Okay, you got it? Yes. Okay, yes. See. Let's add something to this. See, those of you that added frictional force, why you are wrong is simply because of the fact that when we are treating torque, we are channeling all the forces to one side and one force to the other side. Are you saying it? Yes. So assuming maybe you solve that your approach using the principle of say you make this part your fulcrum, then get what friction is here. When you finish getting what friction is here, get what this component is here. Then channel it this way to the center. Channel this one to the center. So when you finish, you should get the same answer. But a situation where you are still channeling all the forces to this side and you are still solving for friction, and this is what you are looking for, that's why you got it wrong. So if I'm to ever use forces at the edges, you can note it down. If I'm able to use forces at the edges, that means I will make the center my fulcrum. So that I will channel the two forces to the center. One thing must be made your fulcrum. I said it in our first class, where I said it's either you make the extreme end your fulcrum, or the other end your fulcrum, or you make the center your fulcrum. Where does what? Coefficient of static friction apply. That's what I said, that I will give you a question 3 that you will solve for me now. That applies to that coefficient of static friction. That they gave it to us. Listen to me. See, that they gave us that this is equals to 0.84. Watch now. That they gave us that this is 0.84. Does not mean that we must solve for friction in this kind of case, because what we are looking for here is RW. And watch, if this ladder is leaning on this, whatever friction that is happening to this one now, as this ladder is leaning, because of this wall, everything should be going this way now. Is it not true? If this is going this way, it should have a parallel force this one as well. Not be so? And this one will be giving it back. Now, because we are finding this and we are saying that we are pointing all our forces to this is because our focus, we have no business with it. So that means that it is not in one way that they ask you such questions like this. There are different ways that they can ask you this question and you are expected to find an answer. So what I'm saying is that you need to understand fully what torque is all about, so that nobody confuse you with a question. I purposely put that question and I added that coefficient of this is this. So assuming you understood what torque is all about, you will still know that that force, for the fact that they are parallel forces, the one here should be equal to what you have up there. And that's not what you're looking for. Ask. Someone, you have question?
Sir, I'll say that that's what I use. I still got it.
That means you use the manual, you twisted, and you still got the same thing. Yes. Unless the way you did it is that you pointed the friction here to the center and pointed the force this way to the center.
I think it's not enough for that. Will not be the same because there is no positive direction from that to plan.
From what you did, you may have gotten it, but I just believe that it's a man, it's magic. Now let me give you one that you will solve for me now, that you must apply that friction. Ask.